Okay, so you guys, in the very first lesson of this unit, like I said, we were solving by graphing. I gave you two equations. I told you to graph them, and I told you to tell me where they intersect. The thing is, you can't always do that because graphing is not the quickest, most efficient method. So we're going to learn how to figure out the point of intersection algebraically. So that means I'm going to give you two equations, and instead of graphing the lines and figure out where they meet, we're going to do that just using the equations. I could ask you for either methods. You should remember how to solve by graphing, but this is what we're going to be focusing on today. So the very first method is called solving linear systems by substitution. And I've given you two equations. X plus 4y is equal to 6. That's equation number 1. And 2x minus 3y is equal to 1 is equation number 2. We're going to solve by substitution. What that means is you're going to figure out the point of intersection. So whenever they say solve, they're basically saying these two lines are meeting somewhere. What is the point that they're meeting at? And then we have to check our solution, and I'm gonna reteach you guys how to do a left side, right side check. Okay, so what is my strategy for doing a question like this? The first thing I do is I look at both of my equations and I try to see if there is a variable that is all by itself. Like, is there an x all by itself or a y all by itself? So when you guys take a look at both of these equations, do you find a variable that's all by itself, Angelique? Yeah, you're going to notice that this x is all by itself. So I'm going to start by equation number 1, and I'm going to rearrange it so that I have an equation that says x is equal to blah, blah, blah. So when I'm doing these questions, I will write down my steps as well. We're going to rearrange for x. That's going to be the very first. Or I'll just say rearrange equation number 1. Maybe that's easier. Okay, so equation number 1 is initially x plus 4y is equal to 6. What do I have to move and where will it go in order for me to rearrange this? Hiroshi? Yeah, I'm going to move 4y over to the other side. So it's just going to be x is equal to x is going to be equal to 6 minus 4y. Everyone okay with that so far? Okay, now what we're going to do is, because this is called solving by substitution, we are going to take this rearranged equation over here, and we're basically going to be subbing it into the other equation. So if you rearrange equation 1, you're going to be subbing into equation number 2. If you rearrange equation number 2, you're going to be subbing into equation number 1. Always sub it into the other equation. So if I want to write it as a rule, I'm going to say sub, which is just a short form for substitute, equation 1 into 2. I'm trying to squish it all in, but I have a feeling I'm not going to be able to do that. So I'm just going to spread everything out and take my space. Okay. So how am I going to do this? Well, I'm going to start off by writing equation number 2, and now everything is frozen. I'm going to start off by writing equation number 2, which is 2x minus 3y is equal to 1. And you're literally taking this equation and you're going to be substituting it into this. Okay, I'm missing my x. I'll just do it like this. This x right in here. So this is going to become 2 bracket 6 minus 4y minus 3y is equal to 1. Question? I didn't forget to put the x. What I did was I literally changed the x to whatever this is over here. So see how it's 2x? Well, I know x is 6 minus 4y. So I took the 6 minus 4y and I substituted into this x over here. So now it's 2 brackets 6 minus 4y minus 3y is equal to 1. That makes sense? So this is why it's called solve by substitution, because you're basically going to be substituting one of the letters with an equation. Yep. Yeah, for substitution, I'll always give you one variable where you can switch. And if you can't, you can still do the question. I think the textbook probably has something like that. All right, let's go ahead and solve this. So we're going to distribute here. 2 times 6 is 12. 2 times -4 is -8y minus 3y is equal to 1. What variable am I solving for here? What letter? Yeah.
Y.
Yeah, the only variable that we have in the equation is a y. So I'm basically moving all the numbers to one side, keeping all the y's on one side, and then solving. So -8 minus 3 is going to be -11y. And then this is going to be 1 minus 12. And I end up with an answer of y is equal to 1. So our next step is going to be solve for x. We've already solved for y. I just take the equation over here. Like I already have a really good equation that says x is equal to 6 minus 4y. And then I'm going to be subbing in this 1 into this. So it's going to be 6 minus 4 times 1. And the answer is just going to be a 2. Now, when we get our final answer, we can't just leave it like this. The question is saying solve by substitution. That means we need a final statement that says, therefore, the POI, that point of intersection, the point where both of these lines are going to meet, is going to be 2, 1. You put the x value and then you put the y value. You think you're done and then you're not done, because look at what the question says. It says check the solution. I'm not going to ask you to check every single solution. In fact, when you're doing your homework, I wouldn't check every one because it's going to take you so long. On an assessment, I'm not going to ask you to check everything. Maybe like 1 or 2 questions I'll ask for a check. And if it doesn't say check, you don't have to do it. But let's walk through how we would check our solution for this. The process is a little bit longer, which is why I don't ask for a check every single time. So you're going to move over to at the bottom of your page or a side of your page. Hopefully you guys wrote a little bit smaller than I did. And I'm going to write down check. Now for a check, what we're going to do is we're going to be plugging in these coordinates into the first equation and seeing if left side equals right side. And then we're going to be plugging in this exact same coordinates into the second equation and seeing left side equals right side. And if our answer here is correct, then in both of the equations, the left side should equal the right side. We did this already. Do you guys remember when we did this last week? But I'm going to go over it again because for some of you guys, your format was incorrect. And it's super important, especially if you get into senior grades, that your format is right for this. So let's begin with equation number 1, which I have on the side over here. I have the left side of my equation, which is x plus 4y. That's the left side. And then I have the right side of my equation, which is, what's the right side of that first equation? Just the number 6. So do you guys notice how I don't have them equal to one another? Because when you're doing a check, you don't know if they're equal to one another. You're trying to prove that, right? So you can't actually set them equal. You have to have them separate. If you want, some people like to have a line of separation just so that they know that they're keeping their checks separate. One is a left side, one is a right side. And you can absolutely do this. Also, you can clearly tell me which equation you're checking. So if you wanted, you could put, this is equation number 1, and it is x plus 4y is equal to 6. All right, so now what are we going to be subbing into the left side, the x's and y's? Yep, exactly. So we have a 2 and a 1. We're going to go ahead and substitute these in and see what we get. Our x is 2 plus 4 times our y is 1. And then we solve this and we end up getting 6. And then our right side is already 6, so that's already done. And so we're going to write, therefore, left side equals right side. Are we done? We've done one equation, but are we done everything, Safir? We still have to do the left side and the right side of the second equation. So yeah, I agree. Checking is a little bit annoying. It requires a lot of work, but if the question asks for it, you have to do everything. So equation number 2 is 2x minus 3y is equal to 1. By the way, check your format. If you let the equation, like if you just write the equation and then start plugging in values here, you will lose marks for format. That's a very poor format. You have to make sure you have a separate left side column and you have a separate right side column. And you don't have to draw a line. That's definitely just optional, but if it helps you, then draw that line to keep them separate. And then do the exact same thing again, where you will sub in the x and the y and see if left side equals right side. My pen is kind of going everywhere. I don't know why. Okay. So the left side of this equation is 2x minus 2 times 2 minus 3 times 1. And this will be 4 minus 3, which is going to be 1. And the right side of our equation is just equal to 1. And then we're going to say, therefore, left side equals right side. And that's the end of the question. Works for me. Okay, question number 2. Which variable is by itself in this question? Safir? Yeah, equation number 2, we have a y that's by itself. So we're going to start off by rearranging equation number 2. So we have 7x plus y is equal to 0. Y is equal to negative 7x. I don't know why my hand is so shaky today. Okay, now what are we going to substitute into where? Like if you were to describe it in words, how would you do it? What do you think, Samira?
I have a question.
Yep.
So would it matter if you made like the second equation equal to like instead of making a y equals minus 7x, you just do like 7x equals y?
Then it would be 7x equals negative y.
Yeah.
You could do that. And then the thing is, though, if you made it 7x is equal to negative y, then where are you subbing it in? Like you're subbing it into this y, which is a positive y.
But I mean, like, what if you have a substitution question, but there's no variable that's like constant?
Then you just pick one equation and then rearrange it, and you'll just end up with fractions, which is possible. I think some of your textbook questions force you to do that.
Are you-
Yeah, I think we'll do one example where we have to do that. Yeah. Okay, so we're going to be subbing in. So I'm going to write sub in equation 2 into equation 1. And how did I know to do that? Well, if I rearrange equation 2, you always sub into the other equation. So our equation here is 5x minus 3y minus 2 is equal to 0. And you're literally going to be taking this equation and subbing it into this x. Oh, sorry, we're subbing it into y, right? So you're going to be taking this equation and subbing it all the way into this y over here. So go ahead and you guys try it, and then we'll see if we get the same answer. 13. Okay, and we were just saying how, okay, good. We were just saying how it's for the x to be a fraction. It just means when we were graphing this, the lines would not intersect very nicely in one spot. And so that's why solving by graphing is not always the efficient method. All right, so we're ready to go on to our third step, which is going to be solve for y. And I just take the equation that's already rearranged, which is y is equal to negative 7x. I'm going to plug this into the x. So it's going to be negative 7 times 1 over 13. You can't really cross reduce or anything like that. So this answer is just going to be negative 7 over 13. And notice in the first question, we found y first, then we were solving for x. In this question, we found x and now we're solving for y. Doesn't matter. There's no rule that you have to solve for x first. You can go either or. But our final answer will be, therefore, the POI is 1 over 13, comma, negative 7 over 13. Now, I lied a little bit when I said we weren't going to check it. I just realized that the questions 3 and 4, we're going to skip them because they deal with stuff that I'm not going to be quizzing. So because we're skipping that, we are going to be checking the solution here. And also I like checking solutions with fractions because it forces you to do a little bit of fraction work. So I'm going to pause. I'm going to give you maybe 4 minutes to try and solve this and figure out what the answer would be. I'll write the solution. I just won't talk about it and you can check your work. Question? Yeah, of course. All right, so we're just checking our solutions. So we're going to have the first equation, which is going to be the left side is equal to 5x minus 3y minus 2. And it's going to be 5 times 1 over 13 minus 3 times negative 7 over 13 minus 2. Are you guys enjoying this? All these fractions. So this is going to be 5 over 13 plus 21 over 13 minus 26 over 13. Because I just made this into a fraction, multiply the top and the bottom by 3. This will be 26 over 13 minus 26 over 13, which ends up being a 0. And that works out really, really nicely because the right side of the equation is a 0. Question, Samara? Yes, you do. Because then here, if you didn't make the 2 into fraction, you get 26 over 13 minus 2. The only way to solve that is to make it into a fraction. So basically what I did here is I made the 2 into like 2 over 1. And then I essentially multiplied this by 13 and I multiplied this by 13 to get 26 over 13. Then I added them together and I got a 0. Question, Sophia? What's the additional step you did? Yep. Okay, yeah, that's fine. Rain? You cannot use a magic number if it's not an equation. So this here is an expression. Even though this is an equation, this, when you're doing a left side, right side check, you're looking at just the right side, just the left side. They're expressions. You cannot multiply by a magic number. Okay, you guys check your format. Make sure you didn't set them equal to one another. And then we will go ahead and do equation number 2 as well, which is, oh, this one's a lot easier. It's 7x plus y is equal to 0. So the left side of my equation is 7x plus y, which is going to be 7 times x is 1 over 13 plus y is negative 7 over 13. And this ends up being 7 over 13 minus 7 over 13. And this is a 0. And luckily, the right side of our equation is also a 0. So we're going to say, therefore, left side equals right side. That's the end of that. Matisha, you had a question?